Hello, today we are in Unit 4, Lesson 7, and we're going to start right away with our jumping in. We're going to use the chart on page 124 in our math journals. Please jump in. Okay, so our warm-up question to get our brains on the metric mass system. So mass is when you're measuring the amount of matter in an object. Our question is, would an average can of beans weigh 400 grams? So that would be on about right here on our line. Or would it be 400 kilograms? So this is a guess. This is brand new information to you. So 400 is way off our charts. How much would a can of beans weigh, do you suppose? Okay, it would be 400 grams. Now I'm going to ask you another question. How much do you suppose a cat would weigh? Now let's just think. Some cats can get pretty big. They can weigh about 30 pounds, some of them. Would it be 25,000 grams or so 25,000 would be way up here, or do you suppose it would be 5 kilograms? 25,000 grams or 5 kilograms? The average cat, 5 kilograms is the answer there. Okay, we're going to use our chart up here to help us with some of our measurement practices. So actually, I will write this on my board here. So 1 kilogram is equivalent to 1,000 grams. We're going to use that to help us. And yes, I am going to do some practice problems with you first on purpose, so that way we can work together to solve these before we jump into our journal. So do not jump ahead, or else you will miss extra hits and extra learning opportunities. So here we go. Devin bought a box containing 30 kilograms of salt. So how many grams is that? So we need to convert it into grams. Okay, so it looks up here that 1 kilogram has 1,000 grams in it. So our equation will be 30 times 1,000. Oi, oi, oi. We're going to have a big number here. So we take our friendly numbers, 3 times 1 is 3, and we count our zeros. 1, 2, 3, 4. 1, 2, 3, 4. 30,000 grams. Okay. So how could we have found that faster using something else that they've given us on page 124? Well, we could look at that scale. So 1 kilogram, or we could even just look at the top. So we go our kilograms, we've got 0, 5, 10, all the way over to 30, which would be 30,000 grams. So we did that correctly. Here we go. Another question. Students collected rocks during the class geology study. Upon weighing them, they discovered they had 2.5, 2.5 kilograms of rocks. So how many grams would that be? So I'm going to put 2.5. So 5,000. What's half of 5,000? Because 2.5 is half of 5. It would be 2,500 grams. Another way we could have done that is we can use our timesing here. 2.5 times 1,000 equals, we take our friendly numbers, 25 and 1, and then we count our zeros, 1, 2, 3. 1, 2, 3. But this isn't our answer because we have a decimal. That means we need to bring it over 1 because it's 1 space after our decimal. We bring it 1 space over. So 2,500 grams. So how did we convert that? We multiplied the number of kilograms by 1,000. What happens when we convert a larger mass, such as kilograms, to a smaller one? Well, it got bigger. Why? Because it takes a greater number of smaller units to represent that same mass. So it took 1,000 to represent 1. So that's why. What would happen if we converted from a smaller unit of mass to, such as grams, to a larger of kilograms? Well, let's say we started with 2,500, okay, and we wanted grams, and we wanted to find out kilograms. Well, that would be smaller. How I could prove that to you right now is, so if we have 15,000 grams and we wanted to go to kilograms, we'd have to take off 3 zeros or 3 spaces, no matter what we are, because we're just dividing by 1,000 instead of timesing by 1,000 to get that. So now we're going to use our book here, and we're going to fill in our charts. So remember we said 1 kilogram has 1,000 grams. So this one we're just timesing by 1,000. So 9 times 1,000 is 9,000. 9 times 1, 3 zeros. This time it's the reverse, like we said. So we're dividing by 1,000. Since we're dividing by 1,000, we have 3 zeros, 1, 2, 3. So we're going to take 3 off, 1, 2, 3. That leaves us with 12. Okay, we'll do the same down here, 28,000. We're going to divide by 1,000. 1, 2, 3. So we're taking off 1, 2, 3. Leaves us with 28. I'm going to have you fill in 18 and 22. These will be timesing by 1,000 each. And jump up to number 2 when you're done with that. I will expect to see those answers, though, when I look in your math journals. Here we go. So now we have kilograms, and we're converting to grams again. So this time is 1.5 times 1,000. 1 times 5 is 15. And we have 3 zeros, 1, 2, 3, 1, 2, 3. But since there's that decimal and only 1 space over, we reverse that here. And we put our decimal there. So that's why they said 1,500. Here we go. So we've got 3,000. So divided by 1,000, because we're going to find this one. 1, 2, 3. 1, 2, 3. Oopsies. That leaves us with 3. Divided by 1,000 down here. 1, 2, 3, 1, 2, 3. So since there is an extra one there, we're going to have a decimal number, 8.5, 8.5. Because we've got our decimal there that they've moved over. So that tells us there's 1 in the back. Okay, again, I'll try up here. So this time now, since we're back to grams, solving for grams, we're going to times all of these. 7.5 times 1,000. So we go 75. And then we count our zeros, 1, 2, 3. 1, 2, 3. But we have a decimal. Since we go over here, we bring it back. 7,500. Your turn for numbers 4 and 5. Again, I expect to see that work in your math journal. We are on to number 3. So please pause the video as you need to, because I know I'm going quick. A deer weighs 13 kilograms. A boa constrictor, so I'm going to write deer above. A boa constrictor weighs 17. kilograms, about how many grams is heavier is the boa constrictor than a deer? So we're going to use this number line to help us figure out. I'm going to go 5. We can go to 20. 10, 15, 20. 10, 15, 20. We're going to fill these in. 5,000, 10,000. Please pause the video, finish writing, and unpause when you're done. Okay, now what I'm going to do is I'm just going to plot this on the line. 13 would be about right here. 17 would maybe be about right here. Okay, so we would take 17 minus 13 equals 4. And now we just convert that. So 4 kilograms. 4 times 1,000. And then we count our zeros. 1, 2, 3, 4,000. Okay, Todd and George took their dogs to the vet. Todd's dog, Duke, weighs 9 kilograms. George's dog, Bruiser, weighs 2 times as much as Duke. So Duke times 2 equals Bruiser. How many grams did Bruiser weigh? So if Duke weighs 9, oops, sorry, that's kilograms. Kilograms go on top. Grams on bottom. 9 is 9,000. Okay, so 9,000 times 2 equals, what's 9 times 2? 18. Count your zeros. 1, 2, 3. 1, 2, 3. 18,000 grams. Okay, number 5. Eric bought 3 kilograms of hamburger, 5 kilograms of hot dogs, and 2 kilograms of steak for a barbecue. How many grams of meat did he buy? So after we do that, then we convert to grams. You'll be doing number 5 on your own. Unpause when you're done. I'll expect to see that work in your journal here. Number 6, Ellen and Jim are checking in at the airport. Ellen's suitcase weighs 25,000 grams. Together, the weight of Jim and Ellen's suitcase is 49 kilograms. Jim plus Ellen equals 49 kilograms. How many grams does Jim's suitcase weigh? Okay, so how we're going to do that is Ellen's suitcase. We're just going to fill in our equation. Ellen's suitcase, 25,000 grams. We want our answer to be in grams. So how many grams are in 49 kilograms? Well, we would just go 49 times 1,000. 49, 1, 2, 3. So now we still have our unknown, but we've got our equation. We're ready with our grams, which is awesome. So now all we need to do is find out how much Jim's suitcase weighs. So I'll let you finish this equation and write your answer for number 6. Buzz's Bike Shop, number 7, received a shipment last week. 3 bicycles each had a mass of 10 kilograms. So each of them. 4 other bikes had a mass of 12 kilograms. You go 12 times 4. 30 was the other one. 12 times 4. 2 times 4 is 8. 1 times 4 is 48. So that's the other set of bikes. All 7 of the new bikes had baskets that each weighed a mass of 1 kilogram. So all 7 of them. So how many were there in this one? There were 1, 2, 3. So this new number is 33 that we're actually going to use. And there was 4 here, so plus 4. $52. Okay, so how many grams total were in this shipment? So this is kilograms. So we need to add those together. 33 plus 52. And now we need to times that by 1,000. 85 times 1 is 85. How many zeros? 1, 2, 3. 1, 2, 3. That was number 7. Number 7 was tricky, so that's why we did this one together. Number 8, 4 schools had a newspaper recycling drive last week. The following are the number of kilograms each school recycled. Dector, that's the name of one school, had 140 kilograms, Boone had 125, Hamilton 190, and Greenlee 164 kilograms. How many grams of newspapers were recycled in all? So think for each school when we hear the words in all. So Dector, 140, 125, 190, 164. So what are we doing when we hear in all? In all means adding. So you can add those numbers together. And then we are converting it to grams. Okay, so but this is kilograms right here, this answer. So I need you to add them up and convert to grams. A scientist weighed out chemicals. She needed 550 grams of sodium. She needed 450 grams of cobalt. So now how many kilograms of chemicals did she need in all? Again, that in all means we're adding those together. Okay, but this time, this is your answer in grams, you're going to convert into kilograms. I recommend you look back at our tables to help you solve. So you're solving number 9, finishing up number 8, and then 5 and 6 are also your job to solve those. Okay, that's our lesson today. We'll talk to you later. Bye.